which was important to understand how we can connect both systems and how is the, let's say, the path going to the consumables, in this case, blocks or Tessera. And today we will have, let's say, the scientific part presented by Eric, and the, let's call it hands-on part. It's virtual, but it's hands-on part by Yaman, showing how easy it is to get out a high aesthetic and strong result, a strong structure, a crown with Tessera. And for this reason, it was important that last week the equipment part showing you all the things what you need, and now finalizing the crown with a few steps. Yama will show that very clear with a few steps, without any big hurdle for even for non-technicians. Everybody will understand that this is a material which make it easy to deliver for the dentist a high aesthetic and strong result. And Eric, as mentioned, and he will start with that, tell you a bit about the what makes Tessera different, because this is the question you have, or we always hear, what is the difference between, let's call Emacs and Tessera? What is really the, what we are talking, it's the next level material. What is this next level material? And Eric will talk about this a bit with all the scientific stuff he knows better than me. And I think saying that, Eric, I will hand over to you. You will start.
Thank you very, yeah, thank you very
enjoy,
much.
Enjoy the day.
Thank you very much, Giacomo. Yes, well, I will be presenting, let's say, the scientific part of CEREC Tessera. It's more the background information, what goes on in the material and why the material behaves as it does, and then what effects that has on the workflow and how the material needs to be handled and can be handled then either in the dentist office or the dental lab. Just an overview slide. I hope you can see all my slides. This is a kind of standard graph we have. On the bottom line, you can see the flexural strength going up to 1000 megapascal and the aesthetics of the material. And well, we find that for example, zirconia, if you remember 20 years ago, zirconia was just a kind of very opaque white material, very high strength, up to 1000 megapascal. On the aesthetical side, it was rather challenging. So it was only used as a structured material which needed to be veneered. In the meantime, the last 20 years, a lot of work was done to introduce shading and translucency. We would call that aesthetical zirconia. With that, you can come to the area where you say, well, you've got good aesthetics, high strength, and still fast and easy handling. This is kind of the utmost goal you want to achieve with the aesthetical zirconia, because all the tricks we have to do, this can lead to a little bit reduction in strength, but there's so much reserve there that maybe even if something is only as 850 megapascal, this is even high. On the other side of things, we've got the feldspatic ceramics, for example, like the Vita Mark II, very low strength when you compare that to zirconia, but the aesthetics is very good, very high because of the good translucencies. Group of ceramics are the glass ceramics. This is where we are placed now with our Celtra Duo and our Celtra Press. And our competitors like the Emacs CAD below the 500 megapascal, quite good or good aesthetics. And here the goal is mainly to try to increase the strength without losing aesthetical side of things. So a different approach to our goal than with the zirconia. We have to keep the aesthetics but increase the strength, whereas with the zirconia we have to increase the aesthetics without losing too much strength. Now with the CEREC Tessera, this is basically our next generation glass ceramic material, where we increase the strength. Very easy workflow, milling, then applying glaze, either manually by painting or by spray glaze, mounting on the investment material pin, and then firing in a furnace. So very easy, 1, 2, 3, 4 steps. Let's now look at the material itself. I've chosen, or usually we choose 3 main topics: strength, aesthetics, and speed. Let's look at our strengths first. Now we dive in very deeply into the material itself. Well, what is the material about? What is CEREC Tessera? Can say it's an improved lithium silicate glass ceramic. That's basically when the customer asks us, well, what is it? Answer is improved lithium silicate glass ceramic. It's basically a material consisting of 3 material phases. The first one is the lithium disilicate. That's something which is observed in nature as well. The second ceramic or glass, the second crystalline phase we observe is the virgilite. This is a new phase in our materials. This virgilite phase has not been observed in Celtra Duo or Celtra Press. Virgilite is nothing which we've now invented. That's basically a substance which is also found in minerals, mostly from Peru, consisting of lithium, aluminium, silicon, and oxide. And those 2 crystal types, they are embedded in a glass, amorphous glass matrix. So we've got this amorphous glass matrix where those 2 crystalline constituents are embedded. How do we know? Well, the first thing we do is always we do an X-ray analysis of our material. This is not done in-house. We give that to universities. And then basically from the X-ray diffraction picture running filters through, we can then determine what crystalline phases we have present. Of course, more interesting for us is, well, how do these phases look? And that's where we then go under the electron microscope. These are the typical pictures we then get with our CEREC Tessera. You can see kind of crystals all jumbled together. They are all embedded in the glass matrix. The glass you cannot see, but, well, it's because it's see-through. And when you look more closely at the crystals, you find basically 2 types of crystals. The first ones marked blue here, they are rather longish in shape. And those are, well, basically rod-like bars. And those are the lithium disilicate crystals. Those are the ones we already find in Celtra Duo and Celtra Press. And the round platelets you find here marked a little bit in magenta. They are a little bit smaller, around 200 nanometer in dimensions, and that is the virgilite material, which we already previously saw in the graph. Those crystals are very small. You can see here that's about, that's 2 microns, and the crystals are below that size, below the 1 micron mark, or even half a micron. That is quite important because when we look at the virgilite itself, that's basically an enlargement of the photograph I showed you before. They resemble kind of wafers. Maybe some of you know of a breakfast cereal. Voids are observed, and the milk gets into these voids. And our working hypothesis for the high strength of our material is these crystals are embedded in the glass matrix, and the glass basically is situated in those voids itself, making a better embedding of those crystals in the glass matrix. So a good interlocking between the crystals and the glass matrix itself due to these voids. That's not yet proven, but there's a kind of working hypothesis we use to explain the high strength of our material. So these virgilite crystals are necessary. When we do measurements with CEREC Tessera, we reach strengths above 700 megapascal. Depends on the shading of the blocks. Some are above 700 megapascal, some are just below the 700 megapascal. But on average, if you average over all our shades blocks we have at the moment, then basically we're just above the 700 megapascal. I think it's 703 or 704. most important is this kind of unique combinations of the crystals, the lithium disilicate crystals. They are formed during the glass melting process. So when we take the glass from its molten state and cool them into the block form, we see that these silicate glass crystals are already formed. But we do not yet see the virgilite. The virgilite is seeded. This means that, like salt in soup, virgilites crystals in a kind of baby form are already in the material, but not yet visible. And then later on, you need a kind of crystallization step. We call this a matrix firing. You would call this kind of glaze firing, where these virgilite crystals grow and stabilize, and that then gives us the 700 megapascal of the materials. If the virgilite is not formed by the second process, then basically strength is about 550 up to 600 megapascal. It was decided by marketing to really go for the 700 megapascal. That's why we need this matrix firing.
So I have here two questions, Eric. I would like to, because it fits here. I have one one question. This was placed not via the chat. That I like to remind. Please use the chat. And now I copy and paste it here. One question is zirconium oxide still part of the structure? You know, with 10%, or is virgilite the one now?
No, it's correct. Zirconia is still in the material, roughly around 10%. It's also still correct that the zirconia is diluted in the glass matrix. So the same story there as with Celtra Duo and Celtra Press. Okay. Only here we've additionally got the virgilite.
Okay, then I have another question. Is this essentially a hybrid material of both glass ceramics and zirconia?
No, I wouldn't call it a hybrid material. Basically, the zirconia which is added is helpful to strengthen the glass matrix.
Okay. And I have another one. What happens with the virgilite crystals when you perform multiple glaze cycles?
Nothing. Basically, it can happen that if you do a third or fourth or fifth firing cycle, that these virgilite crystals could grow, but it has no influence on strength. Bar, you have to keep to the 760 degrees Celsius. If you increase the temperature above 760 degrees Celsius, let's go 780 or even 800 or 850 degrees Celsius, then something dire can happen with the virgilite. But here it's more a problem of that the shade will go off because the material is also pigmented with oxides, and then basically A3 will just deviate and become something very ugly. So you will already notice that something went definitely wrong with your temperature when the shading goes off.
Okay, that means that because it's also part of the same question, how many times we can glaze in this case?
Yeah,
2 times.
I'm going to show that normal glazing is 1 or 2. Some of our user did 3 firings, still okay, but if you go above 3 firings, then basically you come into the problem that your shade will drift away. But 1 or maximum 2 glaze firings should be okay to reach your goal.
And then I have another question. How does 700 megapascal compare to a natural tooth? You know, to the wear of the natural tooth.
We will be looking at abrasion and wear. 700 megapascal is rather high. It's higher than what the natural tooth material is. We need the 700 megapascal if you want to do fast grinding of the material. You need the high strength there, but it's correct. You have to look at the abrasion of the material, and that is not a strength issue. That's a kind of abrasion surface problem. But we'll have 2 slides on that later on.
And now the $1 million question. Which one is more aesthetic, Celtra Duo or Tessera? Now take care what you answer.
Personally, I like the Celtra Duo. but the CEREC Tessera we've got good translucency. We've went rather with the translucency there, so I think the aesthetics is okay there. That's also what's shown on the test. So if you want speed and high strength, go for the CEREC Tessera. If you want to keep it simple and easy, then go for the Celtra Duo.
Okay. Okay, no more questions.
Mm-hmm.
Please.
Now the let's say the killer answer to, well, how does the material perform when in use? We also have to look at the margin stability. So strength is not the only thing. The other thing is, well, how does the material perform regarding the margin? Now, to have good margin stability, you need high strength material and good crack resistance. If you do not have the high strength or any of the crack resistance, then basically your material will not have a good margin stability. In the meantime, the dental industry has developed an ISO test with so-called Merlons. Merlons are those objects you can see on a chessboard, the tower. It's a CAD design where you basically have little turrets, and these turrets have a wedge-like design. So they start, I think, at the thickness of 0.4 millimeters, and they thin out to a minimum 0.1 or 0.2 millimeters. Material is placed into the milling machine, and then the end result is then looked at to see, well, how many of those little turrets still have survived the milling process. You can see if you compare it then to Emax, you have more turrets broken off. So basically the material then should have a reduced margin stability compared to our CEREC Tessera. And this is something which basically you can also observe in the dental laboratory. We find that external and internal dental technicians, they really like the margin stability of the product. We've already had an improvement in that for Celtra Duo, but there's a class more improvement with the CEREC Tessera. So if you're looking for really good margin stability, then go for the CEREC Tessera.
Eric, I have here one question also. Please, again, place the questions in the chat. I copy and paste it. Can we use Tessera like Celtra Duo, like direct after milling, without glaze, just polish, with glaze?
No,
Is it possible?
It needs to be fired. No, it needs to be fired. I'll come back to that later. We need the firing step to get to the 700 megapascal. Now you would think, well, if I don't want to have the high strength, let's do it without the firing, just do the polishing. This is something which could be done, but it's something we definitely do not advocate. The problem being is that the shade actually is set to a firing process. So the end result of the shade, you only get the A3, the A3 on the printed on the block if you go through the firing process. If you do not, the shades will still change during the firing process, and we've adjusted all the pigmentation to achieve the correct shade after the firing. So if you go to a customer and tell them, well, you only need to polish, then basically he will be totally confused because the shades will not be the ones he requires. So definitely CEREC Tessera is nothing just for polishing. It needs to be fired.
Thanks.
Now, as I said as I've shown on the last slide, we have the very good margin stability, and that gave us enough confidence to actually advocate our material with a reduced margin. So if you use the adhesive cementation with our material, you can actually go down to 1 millimeter preparation. If you go the conventional way, that's 1.5 millimeter. And that is the first time that I know with our material that we have the data and we have the support to actually reduce the recommended wall thickness down to 1 millimeter only. For these indications here, we'll use, for example, Calibra Ceram for cementing, for the adhesive cementation. For veneering, we can go down to 0.4 millimeters, then use the Calibra veneer. And then conventional cementing, well, that's Calibre Universal, which can be used there by the customer. But competitor materials will do as well. Only keep in mind, conventional cementing need a little bit more thickness there than with the adhesive cementation. Now, 2 slides on abrasion. Very easy. You have a kind of chewing simulation. You can see here material is placed in a tray, and then horizontal and lateral movement is applied to the material with a certain force of 50 newtons. That's about 5 kilograms. That is repeated 120,000 times. Under water temperature control changing between 5 and 55 Celsius. And then basically after those cycles, the material is looked under a microscope and the wear then measured. The wear is basically a depth, it's kind of dimple, which is then observed. It's a micrometer. And then just look with the Tessera and the Celtra Duo and compare to Emax, the wear is about 0.2 to 0.3 millimeters. And that's exactly what's also observed with human dental enamel. So comparable to natural tooth and our competitor and our in-house material. So the rate of abrasion is comparable. That's not a research which we did in-house here. That's done at the University of Regensburg, as they have the equipment for that. Now, the abrasion of the material is one thing. The other question is, well, what happens to the antagonist? That was one issue which we thought was important with zirconia. If you have a very strong material, it can happen, or you think that basically the antagonist gets abraded away. In Regensburg, they do this test and then not look at the material itself, but then at the antagonist that's made out of steatite. That's a material, also natural material, which is very similar to human dentine. It's a kind of very soft mammaric material. Now. Here, we do not have the micrometer, but basically how much percentage of that material gets abraded. And again, if you compare that to CEREC, Celtra Duo, and Emax, even to Emax Press, that's one of the references as well, you will find that the mean wear of this steatite remains about the same. So we can show here that the abrasion of the antagonist is the same for all 4 materials. So no damage there from CEREC Tessera, even though it has this higher strength there. Okay, that's the first block. We looked at the strength. Are there any open questions for that, Giacomo?
Mm-hmm. I have one question here. What's the difference between Tessera R5.1 and R5.A? What's the difference?
Let me just look. Yeah, I think those were
empty,
different.
Yeah.
Yeah. Basically 2 different charges there. That's an internal numbering there. So those materials are basically let me check on that, what that is.
Yeah. Good question. So good.
Yeah, good question. So helps because you have also the same numbering here. I think that's something that's a numbering sample numbering from the University of Regensburg.
But you give the answer later on, just to be sure, correct?
Yeah, I hope. Yeah, to be sure. Yeah. Okay, now let's look at the aesthetics. That's the second point on our triad of all those 3. If you do not already know, let me talk a little bit about the opalescence effect. The opalescence effect is something which is not new. It's already a point during the last 10, 20 years in dental materials. The basics are, well, you have light which transmits through the glass matrix and then is scattered and blocked by the crystals. That's when you look through a window and any impurities in the window will basically block out the light. So the more impurities you have in the glass, the more light gets blocked out, the darker the glass becomes. But you have a special effect when the size of those crystals are in the region of or the range of the wavelengths of visible light, and that's the case with CEREC Tessera, as also with Celtra Duo and Celtra Press, because if the size of the object has the same or is in the same region as the wavelength of the light, then basically you get an interaction. You get light and crystals which interact. The light gets scattered. Like in a prism, you get cancellation of certain wavelengths. So you get amplification of certain wavelengths. And this creates the so-called opalescence effect. Now, this effect we can see daily when we look in the evening sky. So when we have sundown, get this light scattering, everything or the blue light gets scattered out, and only the red light is left over, and that is why you see a reddish sunsetting. Also occurs in natural teeth. Typical picture we have up here, those are natural teeth once photographed or front lighted or shown with front light illumination. Basically get this blue tint because the blue light gets scattered first. If you have a backlighted, the same tooth backlighted, then you get this kind of filtration out of the blue light, and only the red light or orangey red light is left over, like the sundown or the sunset. We have this effect in CEREC Tessera too. Sample above here, that's a CEREC block. I think that's Celtra Duo, but we also have the same with CEREC Tessera. This is unpigmented, so there's no pigmentation in this block, only the glass and the crystallites. But you can see this kind of bluish and reddish tint. So there's already a kind of inherent opalescence shading in the block, even if you don't have the pigmentation there. Interestingly enough, if you then look at X-ray, basically X-ray has a much shorter wavelength, but even there you get this kind of interaction between the X-ray and the crystals. Probably here more the zirconia crystals or the very small zirconia crystals in the amorphous matrix. If you do a comparison between Celtra and Emax, that was done by Dr. Jagger in the US. If you have a material milled down to the same thickness, that's Celtra here, that's Emax here, and that's Emax then sintered, and you look at the material under X-ray, you will find that Emax basically is not visible anymore. The X-ray goes right through, whereas with Celtra, there's interaction between the crystals and the X-ray. Now, that is very important if you then do X-ray analysis, or if you do radio, take an X-ray at the dentist chair. The dentist would like actually to see the restorations. This one here is an alloy. Here you can see the Emax not so opaque, and Celtra here much more opaque. So the interaction which we see in the visible light is still kind of happening in the field of shorter wavelengths with the X-ray, and that gives you the radio opacity, something which the dentist really likes to see.
I have one question, Eric, regarding are low translucency shades planned somewhere? Is there planned to have to?
No. We find that that our medium translucency are low translucency enough. We wanted to add a low translucency range at the beginning of the development, but later on, marketing decided that the medium translucency is opaque enough. Should the need occur, of course, then we will add the low translucency as well. It's more the other way around. Customers would like to see more high translucency shades. So that has priority at the moment.
Thank you.
Now, we did user tests, dental labs and dentists. Between November and December last year, we did a test dental labs and dentists in Germany. Currently, we're doing one for dental labs in the US. I'm concentrating here on the results from the dental labs. Basically, the results or the learnings are the same as with dentists, but with the dental labs, we get the additional information regarding how the material handles. For example, we asked, well, how's the manual grindability, the polishability, the fit quality, and the margin quality of the objects, scoring from 1 to 5. 1 is very good, so this is the German scoring system here. 1 is very good, green up to a score of average. That's basically, we ask the users to test against their benchmark. Benchmark could be either Celtra Duo, could be Emax, all the materials out there which are available. They had to name their benchmark, and thereby then we could see what benchmarks are being used out there. So everything which is basically in the green side is better than the benchmarks. Yellow is average, what the benchmarks is, and everything which is red basically is has a poor showing. Well, grindability, everything is okay. Polishability is also okay. The fit quality is liked, and the margin quality, you can see here perfect results there. When we look at the aestheticals, let me just show you the number of objects we did. We had 76 cases, 17 evaluators, and the restoration approval rate was 93%. That means 93% of those users said, well, they would recommend to use that crown to be placed in the patient's mouth. Or they would actually give it on to the dentist and have it placed in the patient's mouth. When we look at the aesthetical side of things, we wanted to know, well, how do you like the shade, the transparency, the fluorescence of and the resulting aesthetics? You can see with the shade, everything is in the green. With the transparency, the learning was basically they used the medium translucency for high translucency applications and wanted more high translucency, and that's what we are doing at present. We are increasing the portfolio for the high translucency. Fluorescence, there was some dismay here. Fluorescence with the darker shades is not enough. That's why we have the solution of using the universal spray glaze with flue. We've got it with flue and without flue. So anybody who wants to increase their fluorescency then can do that by using the spray glaze with flue. Resulting aesthetics, that's basically everything combined: shade, transparency, opalescence, fluorescence, and chameleon effect, basically all in the green here. All are satisfied. More than half the customers, or everybody approves, nothing there. Regarding the firings, was that, well, use as many firings as you need. You can see 16 cases were done with 1 firings, 37 with 2 firings, and only 1 firing, 1 restoration needed 3 firings. So basically, mostly 1 or 2 firings were sufficient to achieve the resulting case. Some said, well, they had to learn a little bit how to handle the material. As they got along, they really only needed 1 firing to achieve what they wanted. What is currently on the market? Launch in the US was mid-March this year. Germany 1 month later. We've got currently 10 shades, very much focused on the dental office side of things. Shades are listed here. You can see still poorly on the HT side, very well on the medium translucency. The learnings from the user evaluation or the user test was, well, please increase the number of HT shades. That's what we're doing at the moment. We're adding 2 MT shades as well. And what's still come is the approval to use the veneering with Celtra Ceram. That gives us then full use of the product also in the dental lab. First aim was to place it in the dental office without any veneering, just the glaze firing or the glaze, maybe a little bit of shading there. But should a dental office then, or should a dental lab then want to veneer, that's then possible with Celtra Ceram. It's not a material issue, it's more a shading issue to get the tables correct, shade combinations correct. This should be launched somewhat later this year.
Eric, I have one question regarding shades, shade comparison in this case. We have a colleague asking, how good can we compare the empty CEREC Tessera shades with the empty Emacs or other competition materials?
Not directly. We are not. We are kind of using the competitor to see where our MT shades lie and where their translucency thinking lies, but it's not so that if you take an empty A3 from CEREC Tessera and an empty A3 from Emacs, that they are exactly the same. Translucency basically is starting to play a much larger role in the overall appearance of the object than the shade itself. And each company has a little bit different thinking there of what translucency is. So everybody has starting to have their own system there. Roughly, it's about the same, but if you go into detail, you will find nuances there.
But it means now for a sales rep, for example, that we as a Tensor Sirona have a more compact, let's say, portfolio, not such a large portfolio, which can achieve the colors easier and the strengths, correct?
Yeah, exactly.
Okay.
Yeah, the portfolio.
The message here.
Yeah, the portfolio is basically strong enough to go into the dental office, because if you wait until you have developed all the shades and then you go out in the market, you're already too late. So that's rather compact for the dental office. We thought that the dental marketing and R&D thought that the dental office would be rather satisfied with the MT shades only, but we see that they would rather like to have an increase in HT shades as well.
Okay. Thanks for that. Another question. I have 3 questions more. Any plans on expanding bleach shades portfolio? That we will have a bleach 1 or 2?
Yeah. The bleach 2 is basically just we've basically always got 3 bleach shades: bleach 1, bleach 2, and bleach 3. Those are very easy to do. We've just done the bleach 2, but basically this can be increased any time. Yeah.
The next question: any shade guide will be provided?
Yeah. This is in working. The shade guide is then basically for the dental lab use. It's more intricate. It's basically a good communication tool between customer, i.e. the dental lab, and the dentist. It's not something which is needed for the dentist itself. Because of the selection of shades, that's enough, but we want to use that when we go out to the dental office.
Okay.
To the dental lab. Office, yeah.
And the last question here: is it correct to say Tessera is a ZLS infused by Virgilite, zirconium lithium silicate? Is that correct?
Yeah. It's not infused. Basically, it's not taking the crystals and mixing them up and putting them in the glass matrix. It's basically they grow out of this glass matrix. So the word infusion is always the problem. You always think of mixing up something together. Basically, the crystallites have grown have crystallized out of the matrix. Yeah, but that's basically how you can explain it.
Okay, good. Thanks. No questions.
No problem there. Let's look at speed. And when we think about speed, we think about firing. As I said before, material has to be fired to come up to the 700 megapascal and to get the shades right. So firing is an integral part of this product. Before I come to the furnace, 2 motivations why we need the firing. As I said at the beginning, we've got the lithium disilicate, which is formed during block production, but we need the virgilite to grow. And this is something which is done in the so-called matrix firing. This gives us the 700 megapascal. Of course, then outside in the market, you would then say, well, do the glaze firing with that. And that basically then is this kind of matrix stabilization matrix firing. Second point, or second case in point, which is very important, the firing allows healing of any damaged glass face. This prevents crack propagation. Now you have to think, if you have a very strong material and you put it in a milling machine and you have a very high speed milling, grinding on that material. It's not milling, it's grinding. Glass face is always grinding. If you have a high grinding speed on that material, the material is really stressed. It really gets damaged on the surface, so you get micro cracks there, and you have to get kind of rid of these micro cracks as they can later on play havoc when you get crack propagation. Motivation for that is micrograph. Yeah, micrograph photograph here with a Vickers test. Basically, it's a diamond-shaped pyramid which is pressed into the material, and you can see when you have.
Sorry, sorry. There's some David. David, please put on mute. Thank you. Sorry, Eric. Now
no problem. Clear. I was just trying to listen out if it's a question. Well, if you press this little diamond shaped pyramid into the material at the diamond corners, you get very high stress of the material, and that's why you can see cracks appearing. Now, if you take this material, you've initiated the cracks, and you put this material then through firing at 760 and 780 degrees Celsius, you will see that these cracks, well, they do not disappear, but they get blurred out. And that is basically an explanation, or that's a good reason why you need the firing to reduce the damage of the surface of the material. So you don't have any cracks, which then will later grow when the restoration is placed in the patient's mouth. So basically, the firing is a kind of healing process which does the material good, as it has been stressed out so much beforehand. So that's basically the motivation to do the firing. When you look at speed, well, you say, well, how can you do the firing as fast as possible? That's where our colleagues Dan Splice-Zerona and Bensheim then came up with the Speedfire furnace range, and they have also been adapted in such a way that CEREC Tessera can be used. Firing there only takes 4.5 minutes. This only works if you have a preheating temperature of 400 Celsius. So if the preheating is active, if the furnace is already preheated at 400 Celsius, then basically place the product in the furnace and it will fire away everything in 4.5 minutes. The placement of the object, how many objects? Well, it's only one object which you can place in the Speedfire. The firing procedure, that's then later commented on by Yaman. If you do not use the 400 preheating, then basically firing will take 10 minutes. CEREC Tessera can also be fired conventionally in our conventional furnaces. Then this will take 10 to 12 minutes. So you do not have to use the CEREC Speedfire, but it's something if a dental office looks for speed, then that is the perfect solution. If you compare grinding times and milling, that's something which was requested on Friday when Primary was looked at. Well, with CEREC Tessera, basically roughly 18 minutes for the grinding itself. When compared to other materials, that's in-house materials and competitor materials, you can see that the grinding time is a little bit longer. That's because of the very high strength of the material. You cannot super fast grind it, otherwise you damage it too much. Time which is taken too long here then is certainly shortcut by the glaze firing in the Speedfire. So total time is just under 23 minutes. Of course, if you then do not do the firing via the Speedfire, but conventionally, then basically you have to add another 10 to 15 minutes to this firing time, and then it becomes more conventional. Now, this is the firing table itself, the CEREC Tessera glaze firing program. It's the same for glaze powder and for spray glaze. It's rather conventional, preheating temperature 400 Celsius, heating rate 55 Celsius per minute, maximum temperature 760 degrees Celsius. The whole process takes 10-12 minutes. We've translated this table for different furnace types. also tested those furnaces, EvoClar, CS2, CS4, EP500. We've got the Vita Programmat and the Vacuumat. We've got our own in-house furnaces, the Profire, Multimat Cube, Multimat NT, and Circo Press, and also the Decamar Astromat. So there's a whole selection then of firing tables which have been set out in such a way that the furnaces can be easily programmed step by step as shown on the table. What they all have in common, maximum temperature is 760 degrees Celsius. Because if you go above the temperature, you will find deviation of shades.
Okay, I have a few questions now here, Eric. One which fits perfect to the speed. I have one question regarding, is there a plan to introduce a fast milling for Tessera in the future?
No, no. It's basically at the moment it's fast enough. I think there are some activities to see how you can reduce the milling speed, but that's not something where you actually decrease the or increase the speed at which the burr goes. Basically, it's a kind of recalculation of the whole CAM model. At the moment, it has no priority. But
okay.
will come later on, but I cannot promise that.
Okay, thanks for that. Then the other question is, CEREC Tessera can be used with other milling software or machines from competitors?
No.
Cannot be used, okay.
No, suddenly it's only for in-house use, yes.
For CEREC, okay.
Yeah, for CEREC, yes. Yeah.
Exactly. What is the next question was, what is the expectancy of burr life or for MCXL using Tessera? I think
it is shorter than currently what we observe with Celtra Duo and with Celtra Duo. So it certainly is shorter. The tougher or the stronger material has a negative impact on burr life. Yes, I think it's about 10% shorter.
10% in respect to Celtra Duo, correct?
Yeah. And the problem there is always, this is something which the customer will then ask, well, if the material is tougher, what will it cost me more? Yeah. And if he finds that suddenly he has a high increase in burr usage and cost there, then suddenly Tessera is not that interesting for him anymore. But it's not a vast difference. It's not so that the burrs only last half the time. It's basically about 10%.
Okay, we have a few questions now here. That's good. Are there any plans to add CEREC Tessera as a demo program in the Speedfire?
As a demo program?
Yeah, I do. This question. Are there any plans to add?
Well, basically, it's the firing, the 760. If you the Speedfire is connected up to the milling machine or to the whole computer setup. So what you mill on the machine then basically can only that object is then fired in the Speedfire. So I don't think it has in demo no, but it can be. We can take that one. Yeah.
Sorry, René Vermanen here from the Netherlands. Just to explain my question, in the Speedfire we have these demo programs that we can use to just use the program without milling something. And I know that one of the 4 programs that are in the Speedfire is Celtra Duo. So I wonder if Tessera will be connected with the Speedfire as well in one of those demo programs, so that colleagues can use them.
Yeah, I mean, it sounds easy to do, so why not? But that's something I don't know what the plans are about. I can place the question with the development team.
Okay, that would be great. Thank you.
But I don't see any problem there. Yeah.
Thanks, René, for explaining it. So next question. Why, I think we answered this before, but why would you fire more than once, and does it affect the shade?
Yeah,
why
it does. Yeah, usually, I mean, what we did with the user test was we didn't give the user detailed training. We just said, well, this is the IFU. read it through and just do it. And usually they found that they applied a little bit too, they didn't apply enough glaze. Especially the application of the glaze via spray glaze, you go through a learning curve there, and that's why they find that at the beginning they do not put on enough spray glaze, and that's why they do the second firing. After a while, after 5 or 6 runs, they then find that they can do everything with just one firing. So it's basically down to the learning cycle.
Okay, then the next question is regarding the strengths and the burr wear. Strengths of 700 megapascal have any effect of restoration quantity per diamond burr? I think we answered this.
Yeah. Yeah, it has. Yeah, with one burr you can't do in that many crowns as you could do with the Celtra-2 material. Yes.
And if I'm not wrong, I think in the if we compare with Emacs, for example, we can, and this is fixed in the software, you can do I think 30 units, and with Tessera 25, correct?
Yeah, something
and
about
that.
So with the, yeah. So always with the kind of 15% less is always a good estimate. Yes.
Mm-hmm. Another question regarding the glazing: what temperature do we need for second glazing?
Same,
higher, lower.
Yeah, usually what happens is you decrease the temperatures the more you fire. So a dental technician would tell you, well, second firing should not be 760 but 750. But there you already come in the region where basically the you don't see an effect anymore. So 760 is already a very low temperature for glaze firing itself. Our dental technicians, they found then usually going over the material with a burr, usually then with the kind of polish burr, even gives you the rest glaze which you still require without doing the second glaze firing. So glaze firing is not the second one is not the must. Basically go over the object with the polisher.
Mm-hmm. And now I had the last question, a longer one. I will read it. I'm using software 5.13, and when I grind it with a primal, I saw several crowns cases where the bar was damaged, even so it was new. I was able to glide on MCXL using the same data without any problems. Also, is it recommended to glide in software version 5.2 rather than software version 5.13? That's the question. Should I read it again?
Yeah. Basically, at the moment, I'm just thinking what software versions we use during the application testing. I think it was the new ones. When were they introduced? This year?
Yeah.
5.2? Yeah, we used the older ones because the tests were done last year. So basically, the older versions are the ones which we used for our testing. So these can be confirmed that they really work. The newer versions, usually they then have to be tested on all the materials, and basically there should not be any changes, but you never know. Yeah. But it can basically guarantee the older versions because those were the ones which we used for testing.
Okay, good. Mm-hmm. Now, that means so for us that you have the status you have from R&D is now based on the old of the 5.1 version, and the colleague here used ask for the 5.2. Yes. Okay, good. Yeah. Another one question popped up now. The furnace programs for Tessera not be fired above 800 Celsius due to shade issue afterwards. Mm-hmm. But Empress Cut is at 770 Celsius. Is it correct to recommend this program? Program of customer is not able to program the furnace.
Yeah, but it's not now. Basically, if I would stay very strict and stay within the system which we tested, then I would say only recommend what we do. What was it? Higher temperature, 780?
770.
770. Yeah, it's still okay. Yeah.
Because also part of this question is that the program art CS4 is not easy to program. And the Empress cut is already pre-programmed, you know that, because EvoClive all the programs fixed in, and that could be a solution. Then, you know, if you're not able to put the program in, that you use this fixed program. But okay.
To test it out. I mean, our dental technicians they played around a little bit. The 760 was the kind of optimal. It should not be lower. 750 is really the lowest which it should go. Should not go above the 780. So just try it out a little bit.
Okay, and then another question.
I mean, it has no effect on the material itself. It's just a shading issue.
Okay, good to know. Can Emax or Vita stains be used for Tessera? Can we use other stains for Tessera?
We don't know, because we have not tested that. But basically stay within our family. I mean, material-wise, why not? They have the same
CTE
elongation or same CTE value, but that's theory from where I'm sitting at the moment.
So that means we recommend to use our universal stain in place.
Yeah, because that's tested.
Okay. Thanks for that. No questions now. Please.
Okay, basically I'm nearly finished. Just two more slides to go. We saw strength, speed, and aesthetics. We are all in the clear there. And just basically my last slide there, which is a direct comparison of Celtra Duo and CEREC Tessera. Everything which is in green is basically new, or basically is the highlight for CEREC Tessera. Again, what type of material it is. Of course, this is also zirconia strengthened, but I've left it out here. So it's the advanced lithium disilicate glass ceramic. With Celtra Duo, we have 3 or even more glass phases of lithium. With CEREC Tessera, it's predominantly the lithium disilicate. That's also the reason why we can call it disilicate. The new one is the Virgilite flexural strength, just above 700 megapascal. CTE is in the region where it can be veneered. That was one of the drawbacks with Celtra Duo. You could not veneer it with Celtra Ceram because you will get cracking there. That can be done now with CEREC Tessera, no problem there. Veneerability with Celtra Ceram currently being investigated. Cutbacks and corrections will be possible there. The workflows, with the Celtra Duo, you had the options of 2 workflows depending on what strength you wanted to achieve. With CEREC Tessera, we only do the 1 workflow with the glaze firing with the 700 megapascal high speed. If you do the speed fire, margin stability, again, good news there. We could reduce it to 1 millimeters. Another important point that's more for the researchers regarding patents. Celtra Duo was developed in collaboration with Fraunhofer Institute and Vita. Now CEREC Tessera is proprietary. So it's only us. It totally belongs to Dentsply Sirona. Yeah, that basically summarizes what I've just presented during the last 3/4 of an hour. Yeah.
Okay, then thanks first, Eric, for your presentation, for your slides, for all your input you gave. You see a lot of questions until now, a lot of good questions, I have to say. And now let's hand over to Yaman to the practical part, showing if everything is true what Eric told before. You know, Yaman, now it's up to you. To finalize this. No pressure.
Of course. I am really impressed, and I'm really you know, every time you see a presentation, you may learn something new, even if you know this material and you work with the material for many times. So it was a very nice presentation, Eric, and I really appreciated that I've been also with you. So yeah, today is my part. I would like to say good morning, good afternoon to all faces I've seen before and I've not seen before. But most of you are welcome to this demonstration now. I mean, now is the part where the points comes on the words, you know. So you put the points on the words, and I prepared here something at the beginning to show, and show you the aesthetical part of this material, how it really looks like in the first of all on the model, and then how to achieve and how easy can we get to our result. Let me first just turn the because I need to turn the camera first that you can see a little bit in the main. And I would like to share with you my screen now and give you a better picture. So on the small picture, you can see the whole here. And on the big picture, we can now see what can we do with only one-time staining and one-time glazing. So this is a case I did at the beginning as I got the material. And what you can see here is that you really can put a lot of aesthetical stains, some building some cracks, putting the nice incisal part, and if you just look here, also this is a veneer and this is a crown. If we just went now to the posterior part, which is the main cases are doing or are be done in the dental office or in the clinic. So, and these results are very aesthetic or high aesthetics, and we can get it only through using 2 times firing. The first time is fixing all shades in the right position, and the second part is glazing the surface and protect the stains which you applied. So I prepared now another way, because as we know that dentists sometimes doesn't have that much higher requirement on a very nice aesthetical results. They only have, like, let's say an MOD, and they only would like to glaze it, or they do have a crown in the posterior part and they only would like to have a nice surface in a fast time and only glazed. Yes, we can do it. And when we get the result out of the machine, I think, I don't know how far you have seen last week the presentation of my colleagues from Bensheim with Mario and John, but the way how you get the crown out of the prime mill is like this. So everybody needs to cut in the crown with a disc, with a diamond disc, and after cutting the crown, you will have it this way. So after cutting the crown, we need first to grind the support point here, as you can see, and of course then try to work later with the stains and glaze. But I would like always to keep this support first, yeah, just for me to hold it with the tweezers later as a help for me. That's why I will keep this support, and I will just grind it later when I finish the crown. So we have 2 ways. Either you can apply the Dentsply Sirona Universal glaze, which is in the paste form, as everybody know it, this jar. Or the other way is to spray glaze the crown or whatever you object you have, spray glaze it with the spray glaze. Both ways works very well, and only the application of these both it's a little bit different, as we know. If we would like to use the tweezers and would like to use the high flow paste, it is important to know that the consistencies of the glaze, it makes a big effect later on the result what I get out of the furnace. So if I would have like a nice consistency, which and that's why I didn't mix it before, and I would like to show you the consistency which you can get really a very good result out of it. So first of all, I always take a small amount of this material and I try to place it somewhere clean. And what you can see here, it's a very viscosy material. And if you would apply it on the surface, you won't get a very homogeneous and smooth result. Can you follow me till now? I mean, is everything till now clear? And you can see the picture very well?
Yeah, the image, we can see how you're mixing. The mixing plate is visible. And I have a few questions, but once you finalize, I will, during you
all right. So
proceeding, I've asked you.
All right. So I would like to mix now the glaze, and I'm taking some liquid out of the jar and inside the glaze jar, and I would like to get now the right consistency to apply it easily on the surface. So once I make like a rounded movements and the materials start building a very homogeneous surface, this is the right consistency. And when I would like just to make it a little bit bigger, so if you move your brush later, the material will flow together and build a nice surface. So now, and therefore, I would like to use the glaze brush. As you can see, this is number 2. So if my brush now is very dry, as you can see, it will collect and absorb all liquid out of the mixture I did here. So that's why I first try to put some points beside, I mean some liquid in veneer, and would like to insert my brush into this liquid just to make it a little bit wet. So then I would like to take I would like to show you how to apply the glaze to the surface. So I take that much first, and I just start to apply and slide it down to the margin. So this is the lay I really need. Some of them are applying very less, and this is actually not enough glaze, and because they start mixing the mixture of the glaze, and they didn't get the right consistency at the beginning. That's why they are applying actually only a glazed liquid and not glazed material itself to build, and can get the perfect result. So this is the way now how you can do the how you can apply the glaze on the surface, the normal Dentsply Sirona universal glaze, which is also compatible with many kind of even metal ceramics and the Celtroceram and many other kind of ceramics. So this is the way how I only apply the glaze.
Yaman, one question here. We have you're applying it now with that. We have also this because we know in dental practice the dentist is not, let's say, so fine working. Sometimes it takes a brush, and there's also we have also the silicone, correct, to protect that the material flows inside. Is that to apply the glaze?
Yes, but if you have a crown and you are holding the crown like this,
yeah.
I mean, if you don't go with a brush into the internal surface, of course. But of course,
yeah.
I'm coming to this point later.
Okay, sorry.
Yeah.
No.
So now this is the way how to make only the glaze, and this can do it the technician and the dentist in the dental office. So if we would like to increase a little bit the aesthetical part, and I would like to put some stains to the glaze I'm applying now here, of course it is also possible. So we said the first way is the way I show you here, which is the highest aesthetical way, is first to apply the stains and then cover it with the glaze the way I show you now. The second way is to apply the glaze material and now put some stains into this glaze material and get also better result as it's only glazed. So these are the Dentsply Sirona universal stains, and with these stains I can also achieve a very nice shades in the sorry, just a second. It's hanging. So as example, I would like to apply a body stain now into the cervical part. and increase the chroma in this part. Of course, I can also increase the chroma in the occlusal part, in the central fissures part. And of course, I can also apply some enamels with the incisal material. And what I would like to show you is the shade guides of the universal stains I'm using. So what I use now in the body part and the cervical part is body stain 2. And I would like now to apply incisal 1, which is the bluish one, or the blue material into the mesial and distal part of the crown to increase the illusion of enamel. And at the end, I can use the cream. I think somebody's...
Now they're all on mute, Yaman.
Yeah, perfect. And now I can increase the edges also with the cream. And apply on the tip of the cusp some cream. And of course, increase the aesthetics. I started with a more complicated part to show you later how easy can it also be done. I mean, this is the way to do all in one and just place it into the firing furnace, either the Spitfire or the normal firing furnace, which is, I mean, the one which Eric shows now some minutes ago. Yeah, then we can get this kind of results. Now, as I told you, the dentist sometimes needs to have it like not that much effort. He would like to have a crown which makes which can be done like in 2 minutes. And this for I prepare now another crown, and would like to show you how to spray this crown, how to get the right way. So that's why I prepared in this part a die to place the crown on it, and this is the best way actually for me also to control the shade later on. So if the dentist will show me and give me the die shades, or you can also use any putty material and just press it into the crown. And in this case, I'm using the putty material of the InLab scanner. And make sure that you close the margin very well. So the dentists who are not really sure about using the brush or using by applying the glaze, and would like to make sure that nothing comes into the surface and into the interior surface of the crown, they can use this part of or this kind of putty just to make sure that nothing has just went into the interior part of the crown. And of course, it is very important if we would like now to use the spray, because this is the spray glaze, the new spray glaze, and I would like now to spray the crown. And first of all, we need to take care for that we have covered the interior part of the crown. Second is we have to shake. We need to shake the crown, the bottle very well. And you can hear now that there is two metal balls, and we need to shake them for at least like 30 seconds to get a nice consistency of the glaze which is inside this bottle. And important is also to know that we need like the distance between the spray or the tube and the crown should be like 10 to 15 centimeter. And the best way to spray glaze the crown, you will find it by yourself when you use it like for 1 or twice or 3 times. At the beginning, you might find like some difficulties how to get the right surface and get it glazed in one spray cycle. So that's why my tip is to place the crown on a place and just turn it later. Place it on the place and turn it later while I'm spraying. So you will get with this the best result. Again, I will first spray in the to make sure that everything comes through very well. So, and then the occlusal part. Then we need to wait a little bit and see that the material and there is a chalky lay on the surface. Sometimes the user can see here I have a little bit too less of the glaze spray. Of course, he can apply on the same part again. But with this, you may get a little bit of some rough surfaces like this here. So the best way is to glaze it and you get, or spray it and you get from one shot, let's say, a very nice and homogeneous surface on all over the crown. Of course, better to wear some gloves, but I just forgot it. Okay, then I need to remove the crown, and that's why I told you I kept this part, that I can remove the crown, and of course it happens
the same like in the dental office. Don't worry. This exactly.
Yeah, exactly.
Good example.
So if this happened, this is good that this happened. You just remove it with a brush, yeah, and you spray glaze it again. So let's see it again. Okay, so just gonna hold it again from the same, and then place it on the honeycomb. So these are, or this is the honeycomb for the Speedfire. And when we use it, we need to use it this way. Let's come a little bit more near to the, yeah. So we need to place the crown on the honeycomb and the firing pad. And after, of course, there is some other ways how to place the crown, but important is that the height of the crown should be measured. So either we use the honeycomb or the crown on directly on the honeycomb and the firing pad, or we use the crown on the investment pins, which we also offer from our side, so that you get the same height in the furnace. But if you place the investment pin on the honeycomb and then the crown, then you will get problems with the Speedfire. That's why in the Speedfire, either on the honeycomb without any pins, or only on the investment pins which we offer. And this is the result of the crown after firing. I just prepared it in the to save the time. I think this is the model what they have used, and this is the crown only glazed with a universal spray glaze. So this is how the spray glaze comes out of the furnace after 4.5 minutes.
Okay. So Yaman, I have a bunch of questions now. I think first of all, great. Congrats.
Let me just stop sharing the screen and yep. So now. All right.
Oh, let's start. I have a few questions here, which is good.
Mm-hmm.
First of all, again, thanks for the nice presentation. It looks great, and you show
Thank
both
you.
ways. You know, let's say the lab way, let's say this way, and on the dentist way with the spraying glaze, the fast one. And this generates a few questions, but you see the result is always good, which is great to see. So
Absolutely.
let's start. I have here where to start. So first of all, Gerhard, thanks for your input and your regarding the temperatures. Thanks for that. I've one question is regarding where the crowns you use. You know, at the beginning you showed us the anterior crown, the 2, and the posterior crown. Was this MT or HT? What you used?
MT.
MT, posterior, anterior. Okay.
All of them were MT because at the beginning I only got MT, and I did it in MT. But even with MT, you can get a very nice illusion of translucency even in the anterior part of the teeth.
Okay. Then I have a question, of course, and I expect this regarding the how can we order the glaze plate? You know, the plate you used the Dentsply Sirona glaze plate. How can we order this? Is the ref number? Do we have this information available for all the items you use here?
Unfortunately, we have ordered this. I think we have ordered this from a special small company, and I don't think that there's any ref number for this plates. But it is an issue. Maybe I can discuss with Nicole. So maybe we can come with an answer how we can get some of them if somebody would like to take.
Would be great, so to have a uniform approach and trainings and everything. And I know that the countries are asking for that. Maybe you can come back with feedback, or Nicole then later to the countries about let's say demo material, whatever available would be great. Now I have another question. Holding times from Peter, but be aware of the recommended holding times when you're comparing and using Emacs file. This is regarding furnace. Okay, that we had a question prior to Eric regarding holding times and how to program the Ivoclar furnace, that we can take one fixed program, but the holding times, this is a good point. Thanks, Peter, for that. For the holding times in the Ivoclar furnaces are not the same like we need for our Tessera. This can influence, of course, the color. Okay. This is something I would like you to answer the group. Another question regarding the porcelain spatula you used and the tweezer. I think this is not a part of our own portfolio, correct? This is not a Dentsply Sirona product.
No. This is not Dentsply Sirona product.
Okay.
Unfortunately.
Yeah, unfortunately, yeah. How and when do you use the silicone putty material whilst working on the staining or on glazing process? The question I asked you before. Yeah. When do you use this putty?
I use this putty if I would like to spray glaze the crown, that nothing comes into interferes or enter surfaces. And especially if you have, I'm not talking about crown, if you have like an inlay and you would like to spray glaze the crown or the inlay, and then you must cover the whole entire internal surface with a putty that nothing comes into, because this spray glaze, when it gets dry, it makes like a little bit of add-on on the surface.
Okay.
So this is what we need to take care for.
Okay, I have another question which I can answer directly, because again, asking for sharing the codes for the tweezer and accessories. For the brushes, tweezer and accessories, we learned from Yamen, this is not part of the DS portfolio. The brushes, you can find the brushes in our catalog, because it's the Pinello brush, which is a new one. It's a set of 5 or 6 brushes, which is Yamen has the 2 now in his hand, the number 2. I will find now the ref numbers and put it on the chat if everybody is fine with that. Okay, of these brushes.
Absolutely.
Okay. Now I have a question regarding the staining technique. Can you then add stains to the sprayed crown if you spray first and then you can add stains? Is it possible?
No. You can, in the opposite way, stain the crown and over spray it with the glaze.
Okay.
This will work. And maybe I can also maybe show you in 2 minutes if you're interested to see, but maybe later.
Yeah, because we have a few questions, a lot of questions, which is good. I have here, I think this Gerhard and Yamen, you can exchange this directly. If you have a look in the chart, Yamen, the next question from Gerhard is about the technique. And this is also nice that you share that, Gerhard, because at the end you are also making trainings and best practice sharing about how to spray the best technique. And this is based on Gerhard's experience. Bitte, please, Yamen, have a look on it, answer Gerhard. It would be great, because this is also target we have here, this exchange of colleagues. Now a question here for, do you recommend sandblasting, and which sand size and pressure if you recommend it? Sandblasting the crown before glazing, like with other materials,
Why? The question is, why should I? Normally the normal way is collecting the crown, cut the support point, grind the support point, and then start directly or steam it with a steamer, clean the surface, and then start directly with the glaze. you don't need any retention or any sandblasting to do any more retention for the material, because this is a lithium disilicate, and you don't need to do it.
Okay.
Yes, and you would reintroduce micro cracking. So basically, everything which you've already closed with a crack string firing, you would reintroduce when you do the sandblasting. As you do not need it, don't do it then.
Yeah. Thanks also, Eric. So now this question comes up a lot of times. Can customers add 2 crowns in the same program? And I think we're talking about now the Speedfire furnace.
Okay, if we talk about Speedfire furnace, no, only 1 crown per cycle. If we talk about the other furnaces, which is yeah, I mean, if it's the cube, the multimate cube, or the multimate NTX, or the Ivoclar Programmate, or whatever, we can place many crowns into the firing cycle.
Okay.
Yes.
Thanks for that. I have a question here from Joao, which I would leave to the end because it makes sense. But I will raise the question, Joao. Don't worry. Now, so first of all, here from David here, that the result has been spectacular. Great job. And then the other question, there's here the question: is there any counter indications to use of the CEREC speed paste? You know, if you use the CEREC, any indication or something you do not recommend on that? Should we use speed paste here?
I don't see any necessary point to use the speed paste. First of all, if we will have any anterior crowns at the for example, so we have a form which is also a pertustonite to place any anterior crowns on it as an investment pin, and because we have two forms for the anterior region and for the posterior region, the one I've shown you in the video. So we don't need to do this. No.
No need for the speed paste. Okay, and now I would like to the last question, which was not the last, but now, first of all, thank you for the nice demo. And now the question is to you, Yaman. Can you bring it together in a few words, some important technical arguments to convince the Emacs customer to try CEREC Tessera? You know, bring together what is for you the bullet point to say, try this because it's 1, 2, 3. What should be in your technical aspect here? What can you say to that? It's difficult. I know it's difficult to find the right words, but
no, it is important to see that. I mean, I have many friends of mine, and I know they are Emacs users. Yeah. And the most important thing is that the opalescence which this material can offer, it makes a big sense later on the end result. As we have seen by Eric, he showed the opalescence effects that on the reflected light shows the bluish part of the light. And with the through light, you can get the nice opalescence and reddish part, which is actually in the mouth more than the bluish part. So I've heard many times that people just told me, don't say Emacs, say Greymax. And that was for me like, yeah, of course, because of all the particles what they have, and the grain size which does not let the light comes through the material and show you this nice opalescence effect. So if you would like to get more aesthetic, you can try both crown. I always say try both, doctor, and tell me which one is the best. And he will see for sure a big difference between Emacs and CEREC Tessera.
To summarize, it is the aesthetic
high strength,
one, high strength,
the aesthetic, the high strength, and of course the fast procedure. I mean, if the dentist will take the scan, a fast scan, and fast designing of the crown and milling, so he can produce a crown within 1 hour.
Yeah, that's true.
So in 1 hour he can get the final result crown. I mean, this might be interesting for some dentists, but of course the dental technician can get even better results as the dentist, because they are more in the material and they can get a little bit more out of this material, as I just show you with the anterior case. Yeah.
So just to summarize this, adding the strengths and aesthetic with what you mentioned, the opalescence, that increase the integration of the restoration in the mouth to the natural teeth. That it's one more of the family. You don't see immediately that we have here a crown. That's what you.
Absolutely.
Okay.
And I would also like to add the margin stability, because that is really something which users see. There's a noticeable difference in margin stability between Emacs and CEREC Tessera, and margin stability also gives you reserve when the restoration is in the mouth. So less failures for the dentist, less recalls.
Great. That's true. I have here from Gerhard. Sorry.
But this will be shown during the time comes. It's not something. I mean, the dentist will notice that he will have to do fewer recalls.
Okay. Thanks for that. I have here Gerhard again, and underlining what Eric told before regarding the sandblasting. That the oxides damage surfaces and can cause microcracks. Thanks again, Gerhard, for your confirmation here for that. And I have another question here. How would you handle a veneer for glazing? I think, how will you handle a veneer for glazing?
Yeah, a veneer, I would always put this putty into the interior surface of the veneer. And then it depends about the patient, if I've seen the patient, and it depends about the surface. I always, as a technician, would like to apply the glaze with a brush. Of course, because I can control the surface, I can make some nice texture with the brush. I can do exactly this what I want with the brush. With the spray, you only put some lay on the surface. Of course, it's very homogeneous and very nice and glazy with one shot. But let's say dentists would love to use the spray because he cannot really work very well with a brush. But for us technicians, I think with a brush I can get better results than with a spray.
Okay, thanks for that. And I have another question, a question from Gerhard this time. What is the fluorescence value of the Tessera? Is it similar to the natural teeth? Maybe Eric or William?
Yeah, I mean, I prepared here some we are preparing at the moment a video which especially talks about fluorescency and when to use what. And yes, but in the fluorescency of the material, it depends about shade. If you would have like a bleach shade, you will have like this green fluorescency of the If you would like to increase this fluorescency, you can use the flu option of both glaze, spray or paste. And if you would like to keep the fluorescency So you can use the glaze which doesn't include any of fluorescency.
Okay, thanks for that. And coming back to your previous question, but now Simon, thanks for that, Simon. He meant in terms of placing in the furnace. You know, when he asked how would you handle a veneer, how will you handle a veneer to place it in the furnace? This was Simon's questions here. Is there a special way? Do you on a honeycomb tray? How do you handle this?
Yeah. I will I would handle it. Just place it on the honeycomb and the firing pad.
Okay.
So we don't need any holder or investment pins for this.
Okay. Does this answer your question, Simon? Sorry. Nothing yet, but it seems that I think that's what he meant. Okay. Okay. We are running. We run already out of time. 20 minutes, and I think we should now finalize here. And yeah, I have to say thanks to Yamen and Eric for this really short in time demonstration information session we had today, because you have to know, like the same like with our colleagues Philip and Mario last week, we had a short time frame to prepare this and make it really condensed. I hope this was helpful for all of you to understand this procedure, this workflow from PrimeScan to the material. I appreciate a lot your time that you take your time to learn a bit here. In case of questions, please ask direct our colleagues, same like last week. Give us also your feedback regarding this training. If you felt we need to improve something, please let us know, because remember, this was the first time we did something, bringing, let's say, both worlds together. And from my side also, again, thanks to the colleagues from clinical education, Yamen, Eric, Iris, you know, all the colleagues in Bensheim for the time and the preparation, and looking forward to see you all soon and hopefully live.
Yes. Thank you for your time. Thank you. I appreciate it. I hope it was helpful for everybody. And if you have any more questions, please send us an email or contact Giacomo or whatever way you would like to take.
Okay. Also, thank you from me. Thank you for viewing and listening.
Okay. Ciao, ciao. Have a nice summer, all of you. Ciao, ciao.
Bye-bye.
Bye.
Bye-bye.